Thanks for checking out this 3D Sky video.
So finally getting to do a little bit more fun stuff here with the CNC. I wanted to do a lot of artistic type stuff. There's a lot of fun, designing the stuff in the program, sending it to this machine, and just, getting some really cool stuff out of it. But before we do too much of that, we need to get a new spoil board on this thing. I sort of inherited this thing from my dad. He did things a little bit differently regarding the CNC. So I'm going to do the spoil board a little bit differently. I'm going to put a lot of holes in it, some in this to then screw that new spoil board down to this. We got 3/4 MDF already here. I'm probably never going to use this T-slot channel. It's not the best. There's better things to do now. I'm going to put some holes to screw that one down with some 1/4-20. I'm going to put some 1/4-20 slotted things in here into this, and then 1/4-20 bolts to bolt that new one down to this. I got another 3/4 MDF cut to size to fit onto this, but I need to do a few things to this, mainly surface it. So I'm going to start by just getting a clean surface. There's a whole bunch of raised. MDF's terrible about pulling it up when you screw down into it, which is why I don't really want to screw anything anymore into this. There's people that say, oh, it's the only way. Like, no, there's plenty of other ways. I'm going to show you some other clamps that I'm going to use, and some bench dog holes, different things like that. But I want to get sort of a grid system figured out. So, but before we get too far into that, I need to just surface this bad boy. So I'll show you how to do that in the software. It's real simple. But for now, this thing is mostly prepped. I already have the new piece of MDF cut to size, 48 by 33, I think 32 and some change, but I just went ahead and oversized it to 33. And this is actually 49 inches. That's just the width it came. So I'm just going to leave it. I want a little bit of extra. So this is the Onefinity Journeyman Elite. So it's 48 by 32 is what they call it. But yeah, so I have the tool path in the drive here. I'm gonna power this bad boy up, get it homed. So yeah, we're gonna surface this whole thing. I've got it programmed at just a 0.05 inch depth, so I might have to do it a few times to get all of this stuff off. So then once this is flat, then we will put some holes in this for the 1/4-20 inserts like this, which I'll link to that kind of stuff in the description. All of it's pretty much on Amazon. So we'll get this flat, we'll get some holes in it, we'll screw those down. Then we'll put the new board on here and probably lightly clamp it, maybe. And then we'll put the holes in the new spoil board that the 1/4-20 bolts will go through to then tie into these. I'm not going to do a whole lot of those things. Then we will be putting all of the bench dog holes in, and I'm going to do one bench dog hole at a time until I get the right sizing. And then once I know the exact dimensions for the tolerancing of the bench dog holes, then I'll go back in and program all of them in. But pretty simple stuff. But you want to have a perfectly laid out system that's parallel and perpendicular. Parallel to your X and Y, and then perpendicular to your X and Y, depending on which one you're talking about. That way, when you put some bench dog stoppers in there, it's perfectly in line with your X axis or your Y axis, depending on what you're going to do. And then, like other people you'll see on YouTube, I'll probably put up some sort of just hard fence, parallel with Y, parallel with X. That way I can just shove stuff right into the corner, because most things are going to be square. Start is square at least. You may cut a circle out of that, but you're going to, on your table saw, you're going to cut it to square, shove it in this corner, and then clamp it into that corner, and then do whatever else you're going to do. But let's go ahead and start with this. It's going to be the same general procedure regardless of what kind of CNC machine you have, the files and whatnot. Same procedure, slightly different tweaks that you might have to do, but pop that in there. Every time you start it up, you got to do e-stop. It's kind of annoying, but it helps you be safe, I guess. That's where me goes. I've got 1 1/4 inch really just router bit. I probably need to invest in a better surfacing bit than just that. But it works. I'm going to go a little bit slower maybe, just to be safer. I think I did 100 inches per minute, maybe 120. We're going to watch it, see how it does, and if it needs to be edited, we'll edit it. But so I had already zeroed it. Get this thing out of the way. But I will go ahead and show you a quick rundown of how to zero the height. Every time you change your bit, every time you have to zero the height. So get used to doing that. With the Onefinity, you can get this nice little aluminum block. It's got a full circuit that'll be completed once this touches that. So you put a little magnetic thing right here on the collet right there. You put this onto here. You have to set that up because you take calipers and get exact dimensions on that and then put it in here. I'm not going to go into all that right now. I'm just showing you a general process of how you do these things. You go to jog and probing, go to continuous mode, speed it up a little bit, get about into the middle of that block. And I'm only doing the Z height on this because it doesn't really matter where the X and Y is, because I'm just doing a clearing. Once you have your actual workpiece in there, that's going to be more important for sure. But you can click that little probe button, click right there, hits it, and then it goes right back up. So now that thing knows where the very tip of that bit is. It's very important information for the machine. So I'll leave that right there. All right, so I've got the file loaded. Oh, I get it. I use it perfect. So I'm gonna do a few things here. Programming NVI. I'm gonna start the. That's all right. I just tested that to make sure I'm getting power to my spindle here, or my router, my key to router. Let me go ahead and get the. So spindle up. Slide down. That's to get the suction. Make sure your bit can go through. It can. So now it knows where we zeroed it, and it's only gonna go 0.05 down. Definitely gonna have to do this a few times, but you don't want to do a lot all at once. You want to just go little by little. You don't want to take too much off. But there's a lot of damage that needs to be taken down.
Okay, so here we have our metric loaded up. What we're going to do is just make a quick new file to level our new wasteboard. So measure what your wasteboard is. Mine is approximately 48 by 32, so that's what I'm going to punch in there. Thickness doesn't really matter, but I'm just going to leave it at 0.75. That's what the thickness of the MDF I'm putting on there is anyway. So going to have the zero position be the material surface, not the machine bed. The XY datum, bottom left-hand corner. That's what I prefer. I've got a decent computer, so I'm going to leave it at very high. I like to see what everything looks like when I'm actually running or testing the toolpath in here. Then we just click OK. I mean, you could change your material. I'm not going to. Doesn't really matter for this purpose. So here we go. This is our full MDF spoil board that we have. What we want to do is we want to make some toolpaths that are going to completely flatten this thing. So you want to be making sure that all of your work pieces that go on are flat, or sitting on a flat surface. You might even want to flatten back of your workpiece, whatever you're putting on here, and cutting something out of a 3D image or whatever, then flip it over, then flatten the top piece as well. So you can use this one I'm about to show you here to do that if you choose to. So pretty much what we're doing is a basic rectangular operation. Because this is a rectangle, that's just what we're going to do. So we're going to draw a rectangle. This is going to give us a line to there's a line to go all the way around on the outside, because we're going to want to get the outside as well. Going to, let's zoom in a little bit. Get that right there. You can see it sort of snaps to it if you have your snaps turned on. I wanted to go all the way to the edge of that. It's a little bit high there, so let's go to the middle here. I got one down until it snaps there. And watch it, moving it down. There we go. All right, that one's good there. And the bottom's off. All corners and sides look good. So now what we can do, that's pretty much all we have to do. We have our outside, and then there's a toolpath to just run on the inside. So what we can do is we're going to do a profile toolpath first, and then we're going to select that profile or that line that we just created. And we're going to go, we could go outside the line, we could go inside the line, we could go directly on the line. I'm just going to go ahead and do it on the line. So now what we need to do is do our start depth and our cut depth. Start depth should be 0. Cut depth, obviously don't want to go through the whole board. When I originally did my first one, I did about 0.05, and that was a very small amount. So you might have to do that a few times. It's better to go slower and just increase it. You don't have to sit there and watch it the whole time. So we're just going to leave it at 0.05. We're going to do it in one pass. You could do deeper and do multiple passes if you wanted. I do not recommend doing this within 1/4 inch ending. It's going to take for absolute ever. So if you already have one, which I would recommend getting one if you don't have one, a surfacing bit, it's going to make a much faster job of this. Let's see where, if I have one loaded in here, I should. Something like 1 inch or 1.25 inches. Now I loaded it up before. Where did it go? Right there. One and a quarter inch. Surfacing end mill. We're not going to add tabs. We're not going to do a separate last pass either. So you just creep up on the last one so that you're not chipping out wood all over the place for every one. I'll just make cleaner passes. Don't really need to focus on any of these other ones. The default settings are perfectly fine. If you want to, you can name this surfacing outer edge. Go ahead and calculate. Let's preview that. So, I hate how fast it is. There we go. So that's essentially what it's going to do. Ta-da! Now your edge should be perfectly flat. So now to get all that interior stuff, they're going to do a pocket tool pass to do still a cut depth of 0.05. Not going to do the 1/4 inch down cut. Click select. After here, the surfacing end mill, select that. Move the 1/4 inch down cut. I'm going to do, let's see. I'm going to do the roster at 90 degrees. What happened? There we go. We're going to go up and down this direction. So it's going to start over here, go all the way over there, and then cut this direction. Let's reset preview. Let's... So this is now doing the surfacing interior. And so the reason this will show you why we did the outer box, because when you just do it this direction or this way, it's going to leave these little bits here. You don't necessarily want that. At least I don't anyway. And we might have been able to... So if you want to avoid this happening with just a singular toolpath instead of doing the outside and the whole other toolpath, you could just go into surface, surfacing interior, pocket toolpaths, and just go to pocket allowance, which is going to give you an allowance of how far outside or inside of this original rectangle that we drew. So if you go positive allowance, it's going to push it inward. If you go negative, it's going to go outward. So if you go -1, that should be plenty. It's going to push it out a little bit. Then we can reset preview. We're going to, let's just get rid of this. Delete that. So it won't even do that pass. And let's preview that slip face. So now it went outside. It's going to start and see there's nothing left over here. There's nothing left over at the top there either. So if you wanted to just do a singular toolpath, you could do that as well. Sometimes it might be beneficial to do it in 2 different ones, but this should work fine, especially with your CNC bed, how far it goes out beyond where your machine can actually reach. This might not actually be able to do that far of an allowance outside of where you're actually wanting it to go, because this is technically the full size of your build plate. So your router's probably not going to be able to go out that far. So you might need to do just a profile toolpath with that rectangle just to get a nice crisp line. Otherwise, this might work.
Okay, so now that I got everything loaded into the system, files loaded, ready to go, I did have my X and Y 0 off, so it would have started a little bit over that here and missed some of the board. So all I did was go all the way forward, all the way left, then 0 both X and Y. Don't touch your Z0. It's already been zeroed by the little 0 system there. So if you want your whole spoil board to be done, make sure you redo your X and Y 0 at your home position here. And it's gonna miss. This spoil board doesn't go all the way over to where it is right now. That's fine. All right, I think we're ready to go. I'm gonna go ahead and turn the vacuum on, and we're gonna start this. So you're not gonna be able to hear me. Yeah, let's see how this thing does. Okay, so let that do one quick pass, and it was horrible. Didn't even really do anything. Just wasn't enough cut depth. So one thing you can do without having to like go edit your program and whatnot is sort of just alter your Z0 height, going actually below what the height of the board is. And you may be able to see it or not. There's some screw holes right here in the corner where I zeroed it with the automatic tool height setter thing there. So that may have, because the screw holes sort of go upward with MDF, you know, once you screw something down, it's going to pull that fiber up. That may have made it to where it was just the 0 was so high it wasn't going to cut anything. So I've gone ahead and put the bit, the very bottom of the bit, below the top of the Z height, just by moving the bit all the way out to the front or the side, where however you can do it. Or you can literally keep your Z height as it was and just lower your bit in the collet a little bit. You want to be careful doing that. Obviously, it's better and probably safer to just go ahead and do it in your program. But with how bad this spoil board is, I'm just going to go ahead and force it a little bit, which is what I would call doing what I'm talking about right now. With a brand new spoil board that's already very, you know, flat from the factory, like this new one's gonna be, I probably am not gonna do that. I'm just gonna go one level at a time and just keep going until you get all the way down the whole thing. Another thing to do to make sure you're getting the entire board is take a little pencil and or pen or something and scribble over every part that you're going to go over. That way you can see whether or not the last pass that you've done on your CNC will have actually taken down that part. If there's still some scribbles left over, you need to do another pass. So I'm going to go ahead and find a pencil somewhere. There may be one around here, I don't know. I'm going to scribble that, and then I'm going to go ahead and run it with the forcing it lower, and we'll get this. Hopefully we can do it in one pass. I don't want to do too many passes. Again, this is not even going to be my spoil board. This is just a way to lock my new spoil board down. So I don't care too much about this one. I just want it to be relatively flat, and then we'll flatten everything again. That'll be my really important flat surface. So yeah, let's get that going. So I already did a little test pass here at that forced zero height. You can clearly see that that's going below into the actual spoil board. So that's what we're about to run right now and get this whole thing zeroed out, or flattened, whatever. Okay, so it is completed. Looks like I got all the pencil marks off of where I needed it. There are a few more spots where I don't know what happened here. That wasn't me. Where it's a little deeper. Don't really care about that. I'm mostly just gonna have screw. If I was screwing the new one down right there, it might matter a little bit. It might pull it down. But I'm gonna just be aware of that. I don't want to lose that much more spoil board just for this one corner. So I'm gonna put my little 1/4 inserts just inside a little bit. You will notice the pattern there. That can easily be cleaned up with just a whatever the toolpath is called, just a profile toolpath. If you just do a rectangle in your software, it'll go all the way around and get that. And I will get that. I don't want that there. I want a flat, completely flat line that I'll butt my new one up against it. So I'll put that in my software and then run that. I won't really show you that because it's not really that big of a deal, but I will show you these. So these, if you're not aware, these are bench dogs. They go in hold like that, and then you can butt work up against them. These are going to be obviously deeper than that, and I'm going to get a better sit. But these are nice things to just sort of create a nice flat profile line. You can get a whole bunch of these. They're fairly cheap. And then these are the same type of thing, same size hole, or bench dog holes. They should all be very, very similar size, so they should all fit in the same size hole. But if I were to put these like that, put a piece of work up against this, then I can put that there, and then, you know, put my piece of work right there. They open that like that and close it and clamp it, and I'll show you with a piece of work later. Once I actually have, you know, true bench dog holes, because those aren't bench dog holes. Those are just for those screws there to hold it down. But one thing I need to know specifically, which I already did a quick measurement on, is for this brand specifically, how far that distance is from the front of that bench dog hole to the end of this without it being extended to clamp it. That way I make sure all of the bench dog holes that I program into to drill into the new spoil board are less than this, so that I'll always be able to reach my piece of work. And this is 6.5 inches from that to that, and I'm going to do bench dog holes probably every 4 or 5 inches, and I can always go back and add more. I'm also probably going to add in just straight lines, just in milled into the thing, just so I can have a nice sort of graph to see exactly what's perpendicular and parallel with both my X and Y axes. So just wanted to show you those bench dog things. If you've never seen those before, they're great for woodworking, and they're great for CNC work as well. I'll link to both these or similar products so you can find them easily. All right, now that we got that surfaced, right after I get that cleaned up, then we're going to do some quick 1/4-20 holes for these inserts. So I'm going to get some measurements on these guys. It actually does come with a drill bit with these. I'll see if I can link these if they're still available. I would imagine a lot of these are going to come with a drill bit so that you don't have to guess. Get out of there, one-handed. So you would hope that this drill is going to do the exact hole that those things need. I'm going to do one test and see if that's true or not. And if it's not, then I'll just do an end mill and just slowly inch up on it, and get it to fit perfectly. So these things actually, if you've not seen these things, these actually screw in to the hole. So the hole should actually be, a little bit smaller than the complete extent of that. So you wouldn't want to measure to the end of the screw threads. You really want to measure to the outside of the diameter of the hole. But again, I'm going to try this real quick. If it works, great. Then I can just do single drill holes all around. Otherwise, I'm going to have to do slower end mills. Just take a little bit longer. But I'm not going to do a whole bunch of these. Maybe some spread out in the middle. Not a whole lot. Maybe 3 down a line. And then probably just 1 per each board. So 3 times 5, 15 maybe. We'll see. Okay, so now in order to get the holes in this spoil board for the 1/4-20 inserts, which by the way, I am gonna just end mill that out. The drill that came with it is way oversized. So what you can do is you should certainly already have some calipers on you. If you don't, buy some. Really, any of them that are digital are decent enough. So I want this to be a real tight fit. So I'm going to say 0.3 inches. Should be plenty tight to have this a real good connection, sturdy connection. 0.3 inches is the diameter. All right. So now I need to know where to put them. If I were to just do a 48 by 33 like I did for the roughing, the drilled hole would actually be off the board. So what I can do now is I can use this thing to get the exact, this will work for Z height now because they're all that's completely flat. So I can use that for a good Z height. Let me get this thing out of my way. Now I can get a good X and Y. That way I can offset a known distance into the board in my program, and then go a certain distance. And I need to make sure not to drill a hole here where there's already a piece of metal, a metal bolt there. I need to make sure to drill only where there's not one of these, and I need to make sure not to drill too deep, because underneath these bolts are actually going into metal, obviously. So I need to make sure not to go too deep. So I do need to also take a height measurement of these handy dandy calipers. 0.3 inch diameter, and to get that flush with the top, which is what we want, 0.38 0.3835. If I had my phone on me, I would write that down. 0.3835.3. Let's just try and remember it. Work that brain muscle out a little bit. 0.3835 and which you might want to oversize the depth a tad bit. It doesn't matter. We don't need these things to bottom out, so we can probably go just a 0.4 depth, as long as that's not too deep. And let's check depth real quick. That's one part of the caliper, is this thing. That's a depth reading. So if I put that on the top of these nuts here, oh, okay, so that's a 0.2. So we really have to be careful not to go over these nuts, which isn't going to be too hard. But if it was more than 0.4, then you wouldn't even have to worry. So we will have to worry about those. So 0.4 depth, 0.3 diameter. This will help us get a known distance here. So what I could do is just go in far enough to where it wouldn't even be in this line. But every single one of these is going to be slightly different distances, so I'm going to have to measure those, write all those down to make sure I go in far enough and make sure not to go out too far going here. So what I'll probably do is just get in the middle, get 3 in each board here, maybe 4. So it's either 3 times 5 or 4 times 5, and then go in the middle. I don't have to be so far out to the outside. That's not going to matter that much here. So let's do that. That will give me my 0 to this plane and this plane and this plane. So let's measure and tape measure to the middle of that. From that, it's a total of 8 3/4. So 4. Ooh, what's 3/4 divided by 2? Or approximately 3/4 anyway. It'll be close enough. 3/4, that'd be what, 3/8? Double the bottom number, so 3/4 times 2, it'd be 3/8. So 4 3/8 for the first one. Let me go get my phone so I can write all this down. Alright, handy dandy notes app. Alright, so we said 4 3/8. For the first round of holes, and the distance won't matter. I'll do 33. Well, distance will matter a little bit. We do want to make sure it's far enough into here. So maybe, 3 inches in off both sides. So 3 inches in here, and then 3 inches off of 32, and my true extents. Well, that's not necessarily my true extents. That's my true extents with this width of a bit. If I put a bigger bit, it's going to go even further. If I put a smaller one, it's going to go less. So let's just say, for all intents and purposes, let's do just 32. So we'll do 3 inches off of 32 for the back, 3 inches off the front for the first 2, and then some equal distance between those 2 with either just 1 or 2. I'll probably do 4 times 5, so 20 total inserts. So 4 3/8, 3. So 4 3/8 and 3. Now we need this board and then that board and all 5 boards for the middle, and the offset from the front and offset from the back will be the same for all of them. So let's measure those. All right, so the easiest way to do that is pretty much every single one of these boards is the 8 3/4. So I went to each board and just measured out to 4 3/8 on each one, and then started back over here, then measured and wrote down what each measurement was to the middle. So now we've got all of our middle lines, and that's pretty much all we need. So let's go program that real quick. Okay, so here we are in Aspire
12.5. If you don't have 12.5, it's going to be very similar. So this was what I created to just do the surfacing of the spoil board. So we are done with that. I'm going to make a new one, new file. Still going to keep it 48 by 33 and 0.75 thickness. Doesn't really matter on the thickness because we're not going to be going all the way through the board. So I'm going to pull out my phone and get all of the measurements that I took for the holes that we're going to drill. So we're going to be drilling into the old spoil board. So let's see here. So circles that I'm going to be drilling. Let's see, we're a radius of 0.3 inches. Create that. Close. We're going to move that. Select it. Drag and drop. So keep in mind, I don't really need to do a test for these like I will with the bench dog holes in terms of the actual dimensioning, the tolerancing of the hole, because we're just going to be screwing this thing in there with an Allen key pretty hard. I want it to be tight. I don't want these to move really at all. So I just need to make sure that they are in the right place. That's really what I'm working on here. So I'm going to draw a rectangle 48 by 33. Oh, maybe. Oh, well, I want to radius that. Right. Start over. On that rectangle, that corner, or that corner. I do not radius, I just want square. Apply that. Okay, now we have the 48 by 33 rectangle. So I can now dimension off of that. Okay, so now that we have this circle created, what we're going to do is we're going to go under transform objects and move selected objects. That opens this dialog here. We're going to make sure that we put the anchor point to the middle, which would be this one, because obviously we're trying to put the middle of this drilled hole into a very specific point. The bottom edge or whatever, we want the very middle of that. So we don't want to be relative, because relative would move it from where it is now. Going absolute, that's going to be absolute from this point here. At least I'm pretty sure. Anyway, that point there. So with the measurements we took, remember X is going this direction, Y is going this direction. So the first distance off of the point that we're going to start from is 4 3/8. So the X position is going to be 4.325. 3 divided by 8 equals 375. Okay, so 3, not 325, 375. And the distance up we were going to do was 3. So apply that, and ta-da, there we go. Got 4, 3, 4 3/8, and then next 3. So we can actually go and measure that. And if you look up here, we got 4, 3, 7, 5, and 3. So boom, there we go. We are good to go on that one. So let's go ahead and just select that, copy it, drag it up. We'll do the same here. Move absolute. So the X position is going to be exactly the same, 4.375, and the Y position, so the total distance is 33. We're doing 3 off of that, so it would be exactly 30 inches. So apply that, there we go. Okay, we can sort of just drag that over just to make sure that those are, because this is a straight line here, we can just slide that over a little bit just to make sure that those are, yeah, those are perfectly in line with each other. Now, all right, now that we have those two perfectly in line with each other, we need to take a quick measurement from that middle point to, oh, let's see if we can, that middle point. That distance is 27 inches, so we're going to take 27. We're going to divide that by 3. 9. Obviously, that's 9, but if it was a different number, you would, or a more difficult number to divide, you would just use a calculator like that. So we want to divide by 3 because if we have 4 total holes, then there's 1, 2, 3 gaps in between them. So that's the gap that we need to put in between these. So I'm going to copy that. Nope, I don't want to copy the rectangle. Just copy that. Now I have to transform object. We can do relative now because we're moving it relative to the position it is. We don't care necessarily about the position it is in regards to this point. So we go up 9 inches in the Y. Ta-da! Close that. Then we take that, copy, paste, transform, go up 9 again, and ta-da! So we are good to go. There's equal distance between all of those. Now we can copy and paste these and then move them the X direction relative to what our distances were. So I've got some crazy math here. So 14 and 1/16 minus 4 and 3/8. So if I wanted to go from here, 14 and 1/16, it'd be a little easier. So let's see. What's the easiest way to do this? 6.875. What is that? Point 6.875 times 16. Is 11. So 11/16. So 9 and 11/16. All right. So go over in the X. 9 point. I didn't even need the 0.687. Ta-da! There we go. So that's as far over as we need there. Now we need to do 23 and 7/16 minus 14 and 1/16. Imperial system is not exactly the easiest thing to work with. Copy, paste, transform. Back to Google. So let's see here. What is this? 3 and... Okay, so now that we got our vectors for the holes where they need to be, just do a quick drilling tool path, just like that. Start at 0, obviously. Cut depth, as I said before. Okay, so that finished pretty quickly. However, it's completely wrong. The holes are all in the right place, but it's the wrong tool path. So if you're going to use the drill tool path, you really have to have the exact size drill, because it's just gonna go in each hole. It's not gonna go in and then come up to the size of the hole that you actually drew, the vector that you drew. So it's literally just 0.25 inches. I checked it with the calipers. So what we need to do is the pocket toolpath, and we'll go do that in the software real quick. All right, so this is why I film things and put them on YouTube, because I'm learning, and I'm hoping you're learning from watching me learn, mess up. So the drill toolpath, not correct. What we have to do is the pocket toolpath. This will actually, if I had a drill bit that was exactly 0.3 inches, we could have done it. It would have been perfect. I don't, or if I do, I don't know exactly where it is right now. So if you want to actually go in and then work out to where the extents of your hole are with the smaller end mill or drill bit, you're going to need the pocket tool path. So we've got all our vectors selected. We're not using the surfacing end mill for this. We are using a 1/4 inch end mill. Spindle 10,000. Step over 120 inches per minute. Plunge rate 40. Oh, that looks good. All right, select. Now, it doesn't really matter offset or raster. Well, for a hole like this, offset's probably going to be the best option. Ramp, plunge, this. All right, start depth 0, cut depth. Let's definitely make sure that that's 0.4, not 0.05. Spacey. Pocket allowance is fine. 2 passes. It's 15 duplicate vectors. All right, that's fine. Okay, so there we go. That's actually going to get us the depth, the diameter that we need. Again, sorry about that. I never used the drill tool path before, but again, we're learning. I made the mistake, so you don't have to. So let's see, reset preview. Let's slow this thing down and watch it. So it's gonna, oh, okay, that was way too fast. Goodness gracious. This should be what we need. Let's go try this one out. Let's close this, save that, save toolpath. Okay, so here we have the updated profile toolpath. We're just gonna load this in. Got all the holes there. Yes, it is loaded. Jog and probing. We already have the good zeros. I'm gonna go start the vacuum, and then we're gonna start this thing up, and that should be exactly what we need. Okay, so we're back at the computer. If you were paying attention, I had to, I don't know what the video shows, I had to quickly stop the program because when I started that one, and it did this hole and started this hole, this one was clearly way too big. And this is a good time to point out whether or not you're using radius or diameter. So when I drew these holes, thought I was drawing the diameter. Apparently I was drawing the radius. If you go draw a circle, radius was selected. Dumb. That's not, I need 0.3 diameter, not 0.3 radius. So let's see, it does not look like I can change that easily. Let's see. Yeah. Okay, but I have to do these all separately. Yeah, of course. Okay, there we are. We got all our holes in the right place. We got the right dimension now. The spot, I wish this was more like Fusion 360 or just other 3D CAD software. It's just a little bit easier to use with those. But it's not, so because I would have dimensioned all those and I would have realized, oh, that's not the right dimension. All right, now we can save this toolpath again. CNC is a lot of, especially when you're beginning, a lot of messing up. But just make sure you don't mess up too much and you won't hurt yourself and or hurt your machines. So it's the most important part, be safe. It's better to send your machine to the hospital than you to the hospital. So be careful, learn from your mistakes. All right, let's go do this again. Okay, so I'd like to say that I had remembered to recalculate the toolpath before going out there and trying it again, but I didn't. So if you're gonna change the size of something that you do, You're gonna need to recalculate your file path or your tool path. Now it should actually be the size that we need. Preview. We can clearly see that size. Reset, preview. Clearly a smaller hole. Now I think we've got it. All right, so if you haven't seen and learned by now, CNC is all about try, and try again. At least in the beginning, it's not always gonna be like this. But yeah, all right, now we have the actual recalculated. Yeah, these things are much smaller. You can even see them on there. Alright, work origin looks good. Alright, let's start the vacuum and get this going. Alright, at long last, finally did what I wanted it to. However, I think these holes are still a little bit undersized, and that's my fault. I did say I wanted them 0.3 inches in diameter, but it's a little difficult to, I don't even know if I can actually get that in the hole and then screw it down. Now, I don't want it to be too tight, because then the MDF is gonna bow up and out, because it's just what MDF does. So I'm going to size that up a little bit, maybe to 0.35. Maybe to 0.4. Let's check it on the calipers and see how big 0.4 would be. 0.4 would be too big. I'm going to do 0.35. 0.35 should be maybe too much. No, 0.35. We're going to do 0.35. I'm not going to take you back through that whole process. You saw me do it from the 0.6 to the 0.3. So that's what I'm going to do, and recut them. All right, so this is much better, I believe. So got that in there. Quickly just twist one in. All right, it's got a good feel to it. Looks like it might. Yeah, it's definitely still raising up the MDF more than I want it to. So what I'm probably gonna do is come back on all of these holes with a slight chamfer, because that's quite raised up. So I could have just either gone with a larger hole, but then I'm afraid I'm not gonna have enough grip on the threads. So it's kind of a catch-22. You gotta decide what the best compromise is. I think also you might just need to have a chamfer on there because of just how that head right there looks. So probably gonna do a chamfer just to get that in there perfectly. Okay, so here we're back. We've done the 0.35 hole, put in the 1/4-20 screw hole, and it just pulled up the MDF a little too much. And instead of increasing the hole size, which God forbid I might have to do again, might go to like a 0.375 maybe. 0.35 still looks like a little bit too large. Or no, I did 0.35. 0.4 was definitely too large. 0.375 might do that. I'm gonna try chamfer first, just to see if that'll get rid of that. So what we're gonna do is we're gonna select all these holes here. We're gonna go to the chamfer toolpath. I'm gonna do a 1/4 inch 90-degree V bit. Keep in mind you're gonna have to change your bit. Don't forget to do that. Start depth. Just gonna do 0, Angle 45 with cut depth 0.3. Definitely not 0.3 inches. Maybe 0.25. It's going to be kind of a thing you just have to guess at. Okay, so the chamfer tool bit is a little bit confusing, but as you can see, that's actually what I'm going for there. I don't think you can increase your model resolution when you're already in editing space. I think once you set it up from the get-go, you're stuck to that. I could be wrong. I tried looking up a way to change it, but it did not look like there was any way to change it. Anyway, all right, so let's go back to this chamfer. So we have the hole that we want to chamfer. All right, see both at the same time. So if we were to go inside, we're only going to be chamfering inside of that hole, which would have done nothing here because we already drilled that hole completely out. Inside of that vector, there's nothing left because we drilled it all out. But on the outside, there is. And do we want to slope upwards or downwards? Well, if we're looking at that, that's our vector that we've selected, essentially. Do we want to go from our vector here, so downwards or upwards? Well, clearly upwards. If we select downwards and calculate, reset, preview, that's not at all what we want to do. It's backwards. So we want to slope upwards. Like that, reset, preview, preview all toolpaths. Ta-da! There, that's what we want. Maybe that's a little too deep. Maybe we go like an 1/8 of an inch deep. 1/8 of an inch. No, let's just do a 1/4 of an inch. And on top of that, I am going to increase all of these holes to 0.375, just to reduce some of that MDF pull-up that we're getting. Okay, so the chamfer didn't work as expected. I did increase the size of all the holes, 0.375. It's a decent fit, not really much rise up of the MDF. So I'm just gonna run it. It's not really gonna matter if there's a tiny little bit of raise from some of those screw holes once I flatten this new spoil board. So this is my new spoil board here. I put it up and then butted it all the way up against the little step ridge that's in the back, from the back leveling. So now I've just run it all the way to this end and to this end to make sure that there's approximately the same amount of overhangs, and there is, just about maybe a 1/2 inch or so. There's obviously a little bit of distance between the end here and this, and that's perfectly fine. That's what I want. There's excess on the front side too. And then if we run this all the way to the back, that's what it looks like on the backs. So I can't really see exactly, but there should be some excess back there also. This is not adhered down the base spoil board. What I'm gonna do is probably do the double-sided tape and or not double-sided tape, but 2 pieces of tape and super glue just to keep this in place for now. Then what I'm going to do is do a similar toolpath with the hole drilling that I did for this spoil board down here. I have to make sure not to undo my Z and X and Y 0. That way it'll still be X and Y 0 off of this. That way the hole will be in the same place. So I'm just not going to reset my X and Y 0 until after I get this one adhered. Then this will be my new XY0. Yeah, we'll see. because this might be further beyond my X and Y zero capability. We'll play with those as we go.
Okay, so here we have the wasteboard, the new wasteboard on top. I did attempt to put some not double-sided tape, but some green frog tape.
Where is that stuff? Oh, there.
It's like painter's tape, but this is the green frog tape. It's supposed to be better about something. It's probably just more expensive for no reason. But so I actually did a roll, a whole. Actually, I'll just do it here real quick for you. I didn't get that on video because I wasn't sure if it was even gonna work. It actually did all right, I guess. So you get a long strip, about twice as long as what you actually want. Go back on itself. Stick it on one part that you're gonna be probably your main piece that you're gonna CNC. Stick it on, then stick that to the bottom. You can do this for like the first one or two maybe. Like in the front with such a long piece here, it's kind of difficult. But put one there, lift it up a little bit, use a knife to cut out one side, so you're essentially left with shit. Oh wait, not the smartest way to try and cut tape, but so then you do that. Then this is the piece that's on your workpiece. You do that in as many corners as you can. On the back ones, I wasn't able to do that. I just stuck one piece down, stuck another piece on the top, close to being, because you want them even. You want them exactly in the same place. You don't want one to be here, one to be way over here. Obviously, that's not going to work. So you want them to be as close as possible. So I've got 4, and you can, if you lift up on it, you can tell that not all of them, this front corner is not fully adhered down, but there's no side to side or front to back shaking, which is really all I'm trying to stop. Because I don't want, when it's doing those circles, I don't want the whole board to move, and it shouldn't, but you want to make sure. So did that, and then put some super glue on one piece, all 4 pieces, all 4 corners, then laid it down and sort of stood up on top of this to weigh it down. I did also put some activator on the top part, so I put glue on the bottom part, activator on the top parts, and yeah, as soon as those touch, it should completely solidify. So once I'm done with this, then I can pry up the new wasteboard after getting all these new holes drilled into it. Remove the tape from both sides, and ta-da, you've got your CNC cut piece. So went to Home Depot, got some of this 1/4-20, I think this is just zinc. Yeah, zinc. You don't need stainless steel. That's way too expensive for what we're doing here. So I wanted to get some hex head, but of course the only ones they had were stainless steel, are just way too expensive. I may look for some replacements on Amazon or something. But 1/4-20 obviously is the thread we need for this. And if we get those threads lined up, it should work. For some reason that is not. All right, there we go. Yep, that one works too. It wasn't seated properly, sat properly. So that's what I'm going to use. I got 20 of those. Over cheap is like $7, $6 and change for 20 of those screws, coming back to 5. So now what I need to do is I need to take some measurements of this screw. So you get your handy dandy calipers. Make sure it's zeroed out. I'm going to stick with inches for now. I prefer working in millimeters, but all right. So the minimal diameter of the hole, and diameter, not radius, make sure you're doing it right in the software, is 1/4 of an inch. So I'm going to go a little bit over that to give myself some slop, just in case some of these holes don't perfectly align up, or this one lines up but then this one's off by a fraction. You can, if you give some slop in the hole size for your thing here, you can slide it around a little bit, give a little bit of adjustment. The one thing I want to do is make sure that I don't go so over that my head, obviously, of the bolt slips through that hole, obviously. So it needs to be smaller than that. So that head size is 29/64 approximately. I'm gonna say 15-30 seconds for that, but we're not gonna get anywhere close to that. We'll probably do something like a 5/16, maybe even a little smaller. Maybe I'm gonna say at 9:30 seconds. That's what I'm gonna do. 9:30 seconds, and then now I need to decide how deep into this I'm gonna go. I don't want the head of the bolt to be very close to the top of the workpiece, just in case when I'm going through the piece that I'm cutting out to cut out the profile, you want to be able to dig into this a little bit at least. So with the 3/4 inch MDF, you've got a lot of room to work with. So I'm not that worried about it, but I want to make sure I leave enough on the bottom so that it's not too weak. So I'm gonna say a 1/4 of an inch left. So I'm removing 1/2 inch essentially from this. Hopefully we'll be enough clearance. I shouldn't be digging that deep into the board. So if I'm leaving 1/4 of an inch, and then this size of this head is about 0.16. We'll say 0.17 just to be safe. Plus 0.25. So about 0.42 will be the height of the head once it's fully tightened down in there. So I'm going to do 0.35 on the diameter. 0.35 on the diameter. And I'm going to make sure to leave 0.25. So really I'm just going to drill a 1/2 inch depth. 0.35 diameter, 1/2 inch deep on all of these holes. I've already got the layout of the holes. So that'll be fine there. Yeah, let's go get that program in the computer and get it cut. Okay, so here we have the file that we cut out the holes for our existing spoil boards, and we can use this exact same file for the new one. However, these holes are a little bit larger than what I want to do, because these were for the screw inserts, not the actual diameter of the hole that the bolt needs to go through. So I had said I was going to do, I think, 0.35 on the hole. I'm actually just going to do 0.325. Can always go up, can't go backward once we start over with a new MDF board, and I'm not going to do that. So I'm just going to change all these to 0.325 real quick. Again, pretty simple. Just select it, go to the transform size, and select them all. I'm not going to make you sit here and watch this, but pretty simple. Okay, so now that we got all those resized, let's go ahead and save this as a new file. Let's just put new spoil board there, and let's pin that. I really wish they would let you permanently pin that so you don't have to do it every single time you open the program. Okay, so now that we have that, we also need to go in and we need to make the larger circle for the bolt head to go. Okay, so I love using Excel. It makes everything very easy. So this is we need to know how much to drill out for the bolt head. We need to have the same offset that we do for the bolt size, so that we have enough slop for both the bolt shaft and the bolt head. This is the bolt shaft diameter, the bolt drill hole on the bolt shaft, drill hole diameter. That equals a
increased distance here, 0.075. So this is the bolt head diameter. And so if we add 0.075 to that, then we need this. So that's what we're going to drill out, 0.535. So I'll set this back up. All right, so man, under 2 circles there. So we're going to transform all. No, we're not going to transform that. We're going to do some new hole. Okay, make sure to do diameter. 0.535. That's why it's correct. 0.535. Okay. Close. So to make sure that these are aligned properly, let's say if we did just drawn it like that on accident, we go to align selected objects. We can align a material, which is our board. We don't want to do that. We want to align to a selection. So align selected objects to the last item in the selection. So if you just select both, it doesn't really know what to do. So you're going to select one first. You're going to zoom in, make sure you get the other, hold shift, and then select that second one. Then it remembers the order. So if I do that, then it's going to move the first object selected to the second. So that's what we're going to do there. So now I really wish there was a copy with base point like there is in AutoCAD. I don't think there is. We can copy this. Now I can come here, paste it, and it's just going to paste it where it already is. So if we count, kind of tell that that's clicking into the center point of that, but it doesn't necessarily give you an exact notification that that's exactly where that is. So I really, there are some things I wish that were different than this program, but this is what we're left with. So I'm just going to assume that that is perfectly in line there. Copy and paste that. Once we have one line, we can just copy and paste a whole line over it. I do all of them separately, which is really tedious. Okay, so now we've got that selected. Let's go to select, hold shift, select that. Well, we got both those selected. Hold shift, copy, paste. Now if we zoom in, we've got all 4 of those selected. Okay. Problem with doing it this way is it doesn't realize what this circle is because we have 4 things selected. Really frustrating. Really time consuming. Really now I can actually go ahead and start doing some toolpaths. So I'm going to start by drilling out all of these holes for the shaft. Bolt shaft to just slide through with a little bit of slop. Go through, select all of those. These will be through holes. That's why we have to do them differently than the other larger hole, because that other larger hole will be only 0.5 inches deep. Countersink. There may be ways to increase efficiency, like doing these different holes on different sheets. That way you can just turn one sheet off and select everything. I've not gotten too familiar with Aspire. I'm used to doing mostly 3D modeling and Fusion 360 and SolidWorks. These are largely different programs, but I'll hopefully look into different efficiency things like that. So I'm gonna do a 1/4 inch just to make it quick and easy. I could do 7 extra, it doesn't really matter. Care which. Cut depth 1 inch. We're gonna go 0.8. We'll go all the way through the material, but not much. There's already a hole underneath it, so it's not gonna matter what we're cutting into. And I'm gonna name this bolt shafts hole. Calculate. What do you want duplicate? Care if there's duplicates. Yes, it's gonna go all the way through. That's fine. So let's reset preview all toolpaths. Ta-da! There we go. We did this with our diameter, not our radius, so we're good to go there. Should be the exact size hole that we need. It's a really horrible resolution hole, even though I've got it on high, which is crazy. Okay, now let's go select all the other circles. These are a little bit easier since they're on the outside. I can just hold shift. Inside holes, you can't do that with, obviously. Not in the same way. There might actually be a way to do that. Okay, now we got all this selected. We're going to close that. We're going to do another pocket toolpath. We're going to change our cut depth to 0.5. We're not cutting all the way through. Just going to leave. I'm actually going to do 0.45 because the board may not be perfectly flat along the entire bed. I don't want to cut out too much from one place. It's not much of a difference anyway, but all right, so I'm going to do the sheepy bolt head countersink. Okay, so now we have our machine loaded up with the hole tool paths for the holes and the bolt head. So again, we had to have two paths, one for just this with a little bit of slop, and then one for this with just a little bit of slop. The depth that we wanted, 0.5 inches. So we're gonna load this up. First, what we're gonna do is we're going to make sure we know what bit we had done it with. Well, it should have been the 1/4 inch downcut bit. So let's make sure that that is what is on there. Let's also clean off his bit a little bit. There's a bunch of gunk on here. MDF is really bad about gunking up your bits because there's just a bunch of glue and a bunch of dust with these things. So yeah, get ready for that. So let's jog this over. Look up them. Make sure to put one finger on your bit when you're taking it out, otherwise it will just fall straight out into the ground. So you don't want to damage the tip of your bit or any part of your bit for that matter, but especially the tip. Especially that's a 90-degree V-bit. You don't want to be messing that up because they're not cheap. Okay, so let's load that file, the bolt shaft hole. We got a 1/4 inch end mill loaded as the bit for this, so we're good there. We got it loaded up. We go to work origin. Let's check and make sure that that seems to be. Yes, that is exactly the old 0 point that I'd had. Yeah. And that's what we had wanted. So
let's again go back to work braking. Up. Gonna turn the vacuum on. We're gonna get this thing going.
Oh, goodness gracious.
All right, so I'm at a critical error there, and I'm gonna do my best to not hide any of my errors from y'all, so y'all can learn from the mistakes that I make, because that's really what this is about. I'm not some crazy professional that's had 10 years of experience in all this, and I'm just showing you how easy everything is. No, it's not necessarily easy. It is very easy to make mistakes, and what I did not do there is I put a new bit in, and I put new board on, and I did not re-zero my Z height. Done that many times. It's very easy to forget to do that, even if you've forgotten to do that a lot of times. So what are we gonna do? We are going to bust out the special tool that we have. After, gotta sand that down a little bit because it went straight down into that, and now it's pulled up the MDF, which MDF is horrible about that. So I'm gonna move that out of our way. That little bit of amount pulled up would have changed that Z height by not much, but enough for it to matter. So magnet to the collet.
What?
Now I'm not doing my X or my Y because I want that to be exactly where it was on the old one, which this new one's sticking over X and Y a little bit. So got my magnet on, got this on. I don't want to hold that down because whether you can see it or not, that is moving a little bit. So this is sticking up a little bit off my old. You can see that there's a little gap down there. That doesn't necessarily matter right now, as long as it's X and Y in the right place, then it should be fine. But what I don't want to do is I don't want to push down on this really hard. I want that to be exactly where it's going to be as it is. Then just come touch down. Now we have a new zero for our Z. Now we should be good to go. We're gonna load that file again. It's loaded. Point origin. Exactly where it should be. Start the vacuum. Start the file. So, another problem arose. For whatever reason, the back of my new spoil board is pretty much dead on flush with the old spoil board. Whereas, like, just told you that there's a little gap here. So what that's done is my zero up here is good for this height, but back there it's actually that distance off. So I'm not actually getting through the whole spoil board on those holes back there. So what I'm going to do is I'm going to re-zero it with actually holding this down like I said not to do. In most cases, you don't want to do that, but that will be perfectly fine up here, as long as the bit goes up high enough when it's going to the next hole. Otherwise, it's just going to cut a line in your board. So let's make sure it won't do that. Okay, so now what I've done is I've run the program and stopped it while it's in a travel from one hole to another. So as you can see, there's the hole it was just doing, there it is, and there's the hole it's going to do. And you can see, maybe not in this video, but you would be able to in person, that the height of that it is right now, the safe height that it's at, is substantially larger than this gap that we have here. So if I force this zero to be that, that shouldn't cause a problem in doing that. Otherwise, we're gonna have to go all the way up to the program, change the save ZI, and I just want to get this thing done. Once all this is done, and we pry this up, remove the tape and everything, and we actually tighten this thing down onto the old CNC board, then it'll take all of that air out, and then we're going to resurface this anyway. So all this will be perfectly flat in regards to the X, Y, and Z plane that we have, but this is just to get us through this problem right now. Okay, so now that I have all of the bolt holes through my new wasteboard, and because I have this weird level issue here, I don't want to go and do the counterboard hole, because then it'll be either not as deep on the back ones, or it'll be too deep here if I do the Z level by pinching that down. So I think what I'm going to do is I'm going to make a new program that will, it's essentially the same all along the front and all along the back. The back is all the way down, the front is all the way up. So I'm probably just going to do these first holes in the front. That way I can then go ahead and bolt the front down, which essentially should make the entire thing level at that point. Then I will go through, after the front is bolted down, then I'll go through and do the rest of the holes with the counter bore. But for now, I need to go ahead and take this board off so we can go ahead and put in all of the screw inserts. I'm not going to show you that, it's kind of boring, but that's what I'm about to do. This is the underside of the board. Went ahead and took all the tape off. Notice that there was some glue squeeze out from the super glue that I used. So I maybe going a little bit overboard getting this thing perfectly flat, especially since we're going to surface the top later. But if you're going to do something, do it right. If we're spending this time, we're about to flip it over and bolt it down, so we may as well go ahead and do as much as to this side as we can. So get a sharp chisel. That's what I recommend. Better than sanding down. That way we know exactly what we're taking off. Make sure to get one that's sharp, and make sure to also be very, very careful. I'm using Narex ones, some that my brother bought me a long time ago. Be very careful. Always, if you're trying to take something off a flat surface like this and not gouge into the surface, don't go this direction. That's going to literally dig in. If you go like this and then slowly get that plane right there flat with what you're trying to remove something from, that should not dig all the way in into your actual flat plane unless you go over, right? So just get that flat, get that plane, and just lightly, so move that. It's important whenever you're using a chisel or any knife or anything similar to this, never have anything that you care about in front of it. So you don't want to be holding your piece, because if it slips, if it catches and slips, your finger's liable to come off. Especially if these are sharp. People underestimate how sharp and dangerous chisels are. So never underestimate any shop tool. There we go. Got that flat. Now I'm going to flip it back over, redo the program to only drill those first ones, and then we'll bolt it down. And then I'm going to also screw in the inserts. And if you have one, always put your chisel back up in a safety little hanger tool thing there. All right, well, in the spirit of doing things right, I decided to revisit the chamfer on the holes in the old wasteboard. That is so that anything that happens with this screw insert that goes down, if it pulls anything up or whatever, it won't be in plane with this, because I want that completely smooth so that there's nothing raising up the new spoil board. So I did re-chamfer those, and I really need to look at this chamfer thing on Inspire better, because that's not supposed to look like that. It's not supposed to have a flat spot right there. I don't understand why it's flat there like that. The chamfer toolpath just doesn't quite make complete sense to me. But oh yeah, here's what happens when you test fit something and then you rerun your program. Don't know if you can quite see that, but I broke a 90-degree V-bit, of course. Live and learn. Don't leave anything in. It's not supposed to be in. So all these are good now. I'm going to go ahead and screw in. We'll vacuum off a little bit, and then I'm going to screw in all these screw inserts, and then we should be good to go. Go ahead and put the new spoil board back on. Then we're on the path with just the front holes on the counterboard. One quick note about putting these screw inserts in is it's nice to have a pretty long thing that you can make sure you guide it in as vertical as possible, because they have teeth and you're essentially cutting the threads of this while you're screwing it in. It can go in counterwampus, whatever you want to call it. Askew, I guess is a better term. So you want something, at least for the first few threads, very vertical like this, or even longer if you can. Just make sure it's going to be vertical as much as possible, and that is perfectly below the plane I'm trying to get it below. So there we go. Okay, so I've got the new spoil board up there. Got the new program to just counter bore these first 5 holes. So when I put this up there, I did realize, oh, how do I know if these are perfectly in line with the holes that are underneath them? So I took, I've got these longer 1/4-20s. I just had these laying around. So I went and grabbed them and just threaded them in the inserts that are down there. I did 4 as far away from each other as I could, centered them up as much as possible, and they may be off a little bit because, again, that screw insert may be off a little bit, so it's not a perfect guide, but you can clearly see that that's pretty darn in the middle of that hole, maybe off a little bit. And I did go ahead and clamp it down in the back. That way it can't move, obviously. Those are just random clamps I had that came with the system, or my dad bought them. Don't exactly love those types of clamps, that's why I'm not going to continue using them. But it's nice to have because they're helping me out now, so I'm not going to throw them away. But I don't plan on using T-Track really ever, at least not for this, not for CNC stuff. So yeah, just wanted to explain how I centered this on the holes. Now we're ready to go. Need to change out the bit real quick, and then Z height. Don't forget the Z height. Then we'll get this going. Okay, here we go. We have the front line only counter bore loaded up, and good safety check is always look at this, make sure it looks like what you're expecting, because if it doesn't, you don't have to turn the thing on and make it obvious you don't know what you're doing, like me. All right, so we have that zeroed out with the new bit in there. And it programmed what we want to do. I don't know why, but a lot of times you have to hit rewind before this thing will actually do what it's telling me to change tool. Whenever you see that, make sure you zero out if you haven't already. You're gonna turn the vacuum on and get this thing going. All right, here we go. After a long wait and much work, let's see if this thing goes in like it's supposed to. Nope. So, of course I forgot. I did actually put a screw insert in that one, but if you recall, when I didn't do something properly on that first hole, it dug out a way too big hole, so I had to actually put that one further in. So that one's of course not going to reach it, but hopefully this one will. And it doesn't look like it's going to. Oh, maybe, yeah. Yep, there we go. Perfect. Finally. Try and get that as tight as possible without not going too tight. But let me get these other 4 in here, and then we can run the path on all the other ones. And there we have it, finally. All of our holes, counterboard. Oh, now I just have to put the screws in. That should be quick and easy. Yeah, now that that's done, go ahead and start planning what this board is actually going to look like, where I'm going to do grid lines, so on and so forth. Yeah. All right, so now that I got the new spoil board all tightened down, I wanted to do a little quick sanity check, which is good to do every now and then, just to see if your spoil board needs a new surfacing. So I went to every corner. I zeroed it out here at the home position by eye, not by using this, just because I was going to be checking all other 4 corners by eye as well, so I wanted it zeroed to my eye. So I put it down. Oh, nailed that far. That was dumb. Be careful when moving this thing really fast on continuous mode. So yeah, zeroed it at eye, then lifted the Z up a little bit, moved it all the way back, put it the Z0 there, checked it over there, checked it here. They're all really close to each other, which is what I expected because the bed that we put it on was flat, but just wanted to see. Sometimes you might want to do that intermittently to see if your board is warped or changed before you spend the time doing another surfacing. So that's good. We are going to surface this thing again. Then after that, we are going to be putting in the dog holes and some grid lines and everything. But we'll do that in the software here shortly. All right, so now that we have the new board on here, we need to go ahead and redo the X and Y 0. So put this here on the new plane right there. What? Okay, forgot to put the magnet on, but I caught it. Just gonna randomly stop it there, and then just do it again.
Captain.
All right. Now we have our X and Y 0 to that corner right there, which may actually be outside of our range that I think can fit. So let's see what's gonna happen. So our X and Y 0 points are positive. And what that means is this corner is actually too far out. So what we can do is we can do it manually, which might be easier, or we can do it with a program. We can start a bit like this, go down into the board pretty far, and then cut that way, and then you want to do that from your X and Y 0 as far over and back as you can. Just go down and go backward, then start over, come back here, go down, and then go to the right. That way that will tell you exactly how far over you can get, and anything outside of that you can't get to with your bed. So I'm going to do that right now. All right, so I did just go ahead and run that manually, just all the way this way and that way, starting, going down, doing one little pass, going all the way around. As far that way as you get what I'm saying. Just trimming off everything that your bit will never really be able to get to in the first place. That's one of the downsides about a CNC machine. 48 by 32. It's never going to actually be that. It's always going to be a little bit smaller than that. So went around again through the whole depth, and ta-da, there we have it. That is our little frame that we will just break and just throw away. This is garbage now, but yeah. So that's that. Now our corner over here, that is an exact corner. We can actually get to that. But with what we're going to do, we're not necessarily going to be able to get to that. So what we're going to do is potentially attach something to this side here, or just drill dog holes as close to the side as we can, which will further go into the space, reducing our usable space. But we need to do something here that we can butt stuff up against too. So once we have an actual workpiece, we'll put it up against that. It would be nice if whatever I put here is removable. Sometimes that can come in handy if your piece is just too big, but you're not cutting anywhere near here, you're cutting in here, but you still want some space here. It's nice to be able to remove that. So if it's permanent, you're kind of locked in there. But we could have left on what I just cut off. It might have helped a little bit. But I like knowing that everything inside of this is essentially usable space. So the next logical step is to surface this. Then we can worry about what we're going to do here. Okay, so what I've decided to do, which I saw a picture of online, seems like a pretty good idea. For the front and the left side stop, what I'm pushing my workpiece up against to lock it in place is cheapest and easiest thing to do is just use PVC. I think I'm using 1/2-inch PVC. So that's quick and easy to get. It's very cheap. It's a lot cheaper than those bench dog things. I'll use those inside the area, the work area, but not for the front face. Just use PVC. So this is the first test run of a just a hole that's going to go about right here, just to see what the fit is like. And in fact, I'm actually not going to use my new spoil board. I'm going to use a leftover piece of the old that way I don't waste all of that time and effort and then make a hole that's not going to work. So we're going 1/2 inch deep. I cut the pieces of PVC to 1 inch, so that'll be 1/2 inch sticking up, obviously. So what I'm going to do is I'm going to throw that on top there. I'm not going to worry too much about locking this thing down right now. There shouldn't be that much force on it going back and forth.
Got you.
Don't forget that magnet. Well,
Like,
all right, we changed our bit, so we reset our Z. We also put a new piece of work piece up, so we had to change our Z also. So we'll load that file. That looks exactly like what I want to do. I also got the vacuum set up to where it would start from when the router starts, the vacuum starts. It was confusing to me. I thought you just plugged the vacuum into the controller, into the power supply of the Infinity, but you also have to run it on a separate circuit. So you're actually running power to the back of it from a separate circuit than your CNC is on. Then you plug your vacuum in. You plug power up to this, kind of like you plug power up to your computer, one of those NEMA plugs, whatever it's called. Yeah, so hopefully everything should go right now. I'm gonna go ahead and go to the origin. Control rewind, cycle start. I have that tool in there and I did zero it. Vacuum started like I wanted it to. Of course, I just realized the vacuum's not plugged in. It's not plugged up to the router. Perfect, except for not getting the stuff vacuumed up like I wanted. So your vacuum button on your machine is always plugged up, is always turned on. If you ever need to turn it on intermittently without cycling a work file, you can just turn coolant flood on. All right, so the first PVC hole did not work, so went back and upped it about 15 thou, 14 thou, just a little bit. Couldn't really measure it. Measuring the inside of a hole without really high accuracy tools is just about impossible. So you just sort of eyeball it, and I'm just gonna inch, not inch, I'm gonna fraction my way up. So yeah, and your machine's going to be completely different. You're not going to want to just take these numbers as hard and fast. This is what you should do. I mean, even if you're using the Makita like I am with the 150, you know, you're going to just want to incrementally come up to that number on a test piece. That way, you know, a test piece of the same material, by the way. This is MDF, same 3/4 MDF. So let's see if this one works. All right, that's a good fit. My final dimension on that was, I think, 0.84 inches
for this, and it just barely squeezes out. I can twist it out if I got some pliers, but that thing is in there. That's exactly what we want. Now I do need to actually get that out of there. How do I get that out of there? All right, just got that programmed in to do this line and that line. We can put our PVC in, and then we can do the holes that are gonna be on the interior. And those are gonna be the dog holes. So those are like 19 millimeters. In fact, let's check quick. So these are the 19 size. They're really is measuring at about 18.95, 18.75. Well, that's at the very top there. Oh, wow, that's actually about 18.93 or so. So we'll start a hole at like 18.8 maybe. Definitely want these to be tight. But also you don't necessarily know the dimensioning of your hole. Just because you tell the machine to do 18.8 doesn't mean it's doing 18.8, and it's very hard to measure that very accurately. So you always start underneath and then just creep up on it. So I'm gonna do 0.728-ish inches. And before we go off too quick, let's make sure to measure these two, make sure they're the exact same, because European, UK are 20 millimeters, I believe. Yeah, these are 19 also. And these we don't necessarily want super tight. We do want them to be fairly easy to just take out by hand. So these ones don't have to be super tight. These in the front and the side should be very hard to move by hand because you're pushing something up against it. Granted, you are pushing the opposite direction on the clamps here, but still, these don't have to be as tight as the front and side ones do. And this is why it's good to always watch a program run, at least in the first little bit, because I'm not doing that test piece anymore. I'm doing the actual spoil board, and I didn't re-zero my bit. So I didn't change the bit, but I did change the height of the surface I'm trying to get into. So you got to redo the Z. You'd think I'd have learned that by now, but nope. And there we have a new Z. Now we can start the program. Let's get the vacuum back on. All right, so we've got our bench dog test hole 1 loaded up. We're gonna test that out about right here and see how well it fits. Probably not at all, but we'll see. Just kidding. We need to re-zero the Z. Yep, no fit. So for these, the thing I like to do is bring it in, get that edge right up as close as you can to it, and then get down real close here, and you can see relatively how off it is. It'll give you some sort of idea as to how much more you need to increase, and you still want to go in very small increments, sneak up on it. All right, so I finally got a working size hole for this one. It may be because there's the little chamfered side on this or flat side on this, that this size is different than the other one, or it could just be manufacturing differences because they're completely different manufacturers and different products. So I'm going to lean on going with this size more. The other ones will fit, they're just much tighter. I don't want to go any larger because then this one might not work very well. And this is what I'm going to use most often. So I'm going to stick with this. I think the whole size is 0.74 is what the whole size is right now.
Now I need to go down. I need to increase the depth to 0.72. That's the height of this. I want that to be pretty much flush with the base here. So yeah, 0.72. Increase that depth and remove this, and just go ahead and do all those other holes, which we can always go up in size if I decide to use those other things more. But yeah, let's get it done. Okay, here we are back at the computer. I'm going to talk a little bit about what I've done for the bench dog holes and the general setup of the spoil board after it's been fully secured down. So as we can see, these were the holes that were the bolt hole and the counter bore. All these other ones are, all the ones in the middle here are bench dog holes, other than the bore hole. These are the PVC holes. Currently drilling that out right now. All those. So they are slightly different sizes. So if I go, let's see what I did for the size on this one. Probably need to change 0.8268. Yes, that is still a PVC size hole. So I'm going to change those to 0.7. I want to do about 0.8. What did I say earlier? About 18 point. I'm going to start at 18 millimeters, and we will go up from there until I get a good fit. Then we will copy out these rests. So I'm not gonna. I'll show you how to make an array of these once you get the right size, so that you don't have to go click each individual one and change the size. That's time consuming. We don't want to waste time. So what I'm going to do here is I wanted to do 18 millimeters. So I'm going to do 18 times I equals. Yes, you can do some formulas in these little cells here. So you put in the millimeters that you know 18. So 18 times I. So it's just going to have to multiply it or divide it by 25.4 to get what the inches equals. You do the same with, you know your inches and want to go to millimeters, you do, let's say 1 inch times m equals, and then ta-da, it'd be 25.4 meters. So that's that. You're going to apply that. Make sure to apply and watch it change its size. Unless you don't, then it may not have changed size. So we have that test hole there now. And that's for the bench dogs. So once I have my SD or my thumb drive back from the tool, the machine, I can put that on the thumb drive and then go cut it on the test piece of MDF. So let's see, that is going to be the bench dog test hole 1. Save that to my toolpath for the spoil board. And so let's say that is the correct size. Under the offset and layout, there's an array copy. So you click on what you want to, you either click on array copy and then select your thing, or select it and then it'll automatically be array copying that one. You can do both X and Y at the same time. Let's assume you do want to do that. You tell it how many copies you want. So this is going to include what you're starting with. So if you're wanting 3 total, including this one, you would put 3. If you want to make 3 new ones, so this one, 1, 2, 3, you would actually want 4. So that number is going to include what you're already starting with. Then you choose gap or offset, and I want to offset these. I want them to be an exact distance from center points, not exact distance between the outsides. So we select offset, select 2 there, and what I'm also going to do is just delete some of these real quick.
we can actually see what it's gonna do. So we've selected what we want, and ta-da! So I copied 1, 2 out that way, and then 1, 2 out this way. What it also did was it not only copied that up this way, this one this direction, and then this one this direction. It also knew we wanted to make these in here as well. So that's just an easy way to make a very quick grid array. So what I've done is I want to keep my maximum distance below 5.5 inches, because that's the length of my bench dog clamp. So what I've done is I've decided I measured out this direction to the end here. Technically that's 7.5, but this one is closer. This is my closest one on that distance there. So that's about 4.4 and 4.58. That direction and this direction. So if anything was just super small in here, that's gonna clamp it completely. If I have a bigger piece, then this one might come in handy. This one might come in handy. So I'll probably have I won't have another hole here, like right here, where if I continued my full array here, there would be one there. There doesn't need to be one there, because I'm not going to ever really be doing anything that small, I don't think. If I do in the future, then I can make a new one, or make some other way of clamping something down. So this is what I'm going to stick with for now, aside from the size of the hole. That'll change a little bit. Some of them will run into our holes here. So this one, I'm just going to delete that. We can't do that one. This one's close, but it should be fine, I hope. Some of our measurements have changed because I took the whole edge off the outside. So this is not the same distance here. This is actually closer. So if anything, now my 0 point's like right here, that actually should be further away. So we're good to go there. That one is probably still going to be an issue there. But I probably don't need one there either anyway. I did have to remove one over here because it was too close to that one. A few other places, like one more. So yeah, that's the process of doing that. You can lay it out however you want. It's not gonna matter that much. You do just want to be cautious as to how long your clamp is. If your clamp can only do 4 inches and there's 10 inches between your between this and here, well, your workpiece better be 6 inches or more, really a little bit over 6 at least. That way your clamp can actually reach it. So that's really the only thing you want to pay attention to there. There are other ways to clamp as well. Something that I'm going to be doing also is instead of using the bench dog clamps all the time, you can just put one of the bench dogs in, like I've got. Let's say one there, there's one there, and one there, and one there, and one hold up there. You get just an angled piece of wood, and it just wedge locks it. So you get something like that. There's a bench dog there, and your work pieces. So your work pieces like that. And then you can just get a wedge right here and just hammer it in there a little bit. And then you don't need clamps. So this can come in handy. You can make wedges of all shapes and sizes pretty easily if you have a wood shop. So that's another good, quick, and easy way to use bench dogs as a clamping method.
All right, so as you can see here, we've got all those holes here for the PVC, down the X and down the Y. I've gone ahead and made some adjustments to these holes in my program. What I did is I made a measurement from here to the middle of that circle, and from there to the middle of that circle, and selected all of those holes in my software and pulled them down, or really moved them up to where they should have been, so that I know all the holes that I'm about to drill aren't going to drill straight into some metal. If I did everything correctly, then hopefully we won't have that problem. I did change the size of the hole from 0.74 to 0.735, took off 5 thou. Hopefully that'll get it a tiny bit tighter on these, on this guy here, because it was a tiny bit loose. I'd rather it be a little bit tighter. Here we have the layout, we've checked that. Now I did remove that board, the test board, so we need to re-zero this. See, I'm learning. I hope you are too. So here we are the next day. So this is the second bit I've broken in this whole escapade. Yeah. So got most of the holes done. Most of them. Literally the last few little holes was a little too close to some of these screws that I put in. That one was really too close. Literally just drilled straight on down through it. Did some damage to the bit here. It wasn't destroyed there. Came to this one. This is the one that destroyed the bit. As you can see, it's the last hole. There's supposed to be another one about right there, and there should be another one about right here. Probably would have hit that one too. I offset everything. It looked good in the program. Clearly, it wasn't good. But you're gonna make mistakes. Hopefully, you make less watching me. Probably should have just double checked everything. But I lost a bit. Oh no, that's gonna happen. That hole is actually still usable. This hole is still usable. That hole is usable. So we broke a bit. It's just how you learn. So be very careful when you're going deep enough to go into something that is metal. And I knew I would be right there. And yeah, I wasn't careful enough. So you'll make mistakes. Just try not to make it a second time. But now, I'm not really even going to care about these holes here, probably. I might put them in later. But now we have places to actually put our clamps. And that's our spoil board. So I'm going to put some... Actually go ahead and put the PVC in there. So that'll be ready to go. And then we can actually start working on some projects. And tomorrow's Christmas Eve, and I've got a few projects I need to work on to give people. So I'm going to be showing y'all some of those in the software and getting those going. And hopefully by next Christmas, if you actually watch this video, you'll be able to make something yourself. And hopefully not waste too many bits. Alright, so I've got the PVC in there. Just to quickly show you how this works if you've not seen it before. So those just give you a nice corner to go into. Nice little gap there. Whatever corner piece you have to go through there. But this is not a perfectly... This was just a test run I did. So it's not perfectly square. So it would help if it was. These PVC things are square. That's just a piece of 2x that I was doing as a test run for this that I did for a friend. So yeah, you just throw these in some strategic locations. Cinch that down, and then actually I'm probably gonna have to for sure get that hole in there. So I am gonna program that one in Obviously this would work here, but it's just nice to have multiple locations. It's probably going to move just because it's not perfectly perpendicular on that, but there you go. That's how you lock a piece of work down without having clamps up here. I don't like having clamps up on top, so I should just have very low profile things, and that works very well. Let's try not to break any more bits.